Right, so antiderivative of tangent is the same as antiderivative of sine over cosine. In the past, we looked at problems where we had sine and cosine and one had an exponent. We made whichever one had an exponent our u. In this case, we're going to make the denominator our u. And du is going to be negative sine of x dx. Which means we need to multiply the inside by a negative 1, outside by a negative 1. So we have a negative on the outside times the antiderivative of 1 over u du. Right? The negative sine of x dx, that becomes our du, and the cosine of x, that's our u. Well, this is simple now. We just have negative natural log of absolute value of u. So in this case, that's cosine of x plus c. So there's our antiderivative. This is one we're going to need to remember. So if you scroll down here or look down here, antiderivative of tangent of u, negative natural log of absolute value of cosine of u plus c. But this one has another option. The other option comes in because we have this negative 1 out in front of natural log. Well, properties of logs, we can bring that and put it as an exponent here. Right, so really we could have natural log of cosine to the negative 1, but we're not going to write cosine to the negative 1. What is cosine to the negative 1? Secant, right? It's 1 over cosine, which is secant. So we'd have natural log of absolute value of secant of u plus c. So either one of these can be used for the antiderivative tangent. Generally, I'll use this one just so we don't have to worry about the negatives, but either one is fine. We don't have time to go through all of the other ones and like do them by hand, so let's just kind of write these down. These are all ones you're going to need to remember. Antiderivative cotangent of u is natural log of sine of u plus c. Antiderivative secant is natural log of absolute value of secant of u plus tangent of u plus c. And antiderivative cosecant of u is natural log of absolute value of cosecant of u minus cotangent of u plus c.